This example right here is hugely important. I love this one. It's kind of, you see all kinds of problems just like this. We're talking about it more on the engineering side of things, but there's problems like this all day long. You ever remember, like, if you ever given the problem where it says if one guy can paint this wall in 2 hours and another guy can paint it in 5, then how long can they actually paint it if they're doing it together? That's pretty much what this problem's all about. Because what's happening here on the left is it's saying you have a circuit that has 2 resistors on it. It's like basically what would happen if you put it together and combine these 2 resistors together into one, then how much is really being required? And that's what's going on. So it's saying, suppose that R1, the resistance of 1, is 4R2 plus 100 ohms, and R is equal to 100 ohms. So we want to find R1 and R2. And the equation that you use anytime you are given one of those situations where it says, okay, if one person can do it in this long and another one can do it in this long, how about they join up? How long will it take? This is your equation every single time to use it. So whether it's circuits, whether it's painting, whether it's if a guy can run, oh gosh, maybe running's not the best plan, but you see what I'm saying? It's just anytime you want to see what it would take to join these 2 atoms together, this is your main equation. So if anything of this whole lesson, y'all memorize this equation. It's really beneficial to know. Okay, so let's get started with solving this. We've got kind of several variables going on here. We have R, we have R1, we have R2. So it's like, how can I solve an equation when I've got 3 different variables going through here? Well, that's kind of why they've given us so much information. They said our initial resistance is 100 ohms. So I'll say 100 is equal to R1, which is coming through here. R1 is equal to all of this right here. So it's equal to 4R2 plus 100. Just taking off my units when I'm doing this. Times R2 all over R1 plus R2. Well, R1 is 4R2 plus 100 and then plus R2. Okay, so all we have to do right here is just finish solving it out, and then most likely it's going to be quadratic, I would imagine, because we're in the quadratic section. Well, to get rid of the fraction, let's multiply the left side and the right side by the denominator. So that way we can clear that off of that. And let me scroll down some more to give us some more room. So 100 times that left side would give us 400 R2 plus 100 times 100, so 10,000, plus 100 R2 is equal to, multiplying this out, so 4 R2 squared plus 100 R2. Alright, so y'all are seeing there's our quadratic term right there. And because of that right there, it means I want 0 on one side and everything else on the other. So when I go about doing this and moving all my terms over, combining like terms and all that, y'all can kind of, I trust that you can do this. We'll just kind of finish this up a little faster, but it'll be 4R2 squared minus 400R2 and then minus 10,000 equals 0. Okay, so let's finish solving this out. Obviously, the easiest way to do would be, first of all, let's shrink it down, divide everything through by 4. So we'll get R2 squared minus 100 R2, and then minus a fourth of 10,000 would be 2,500. Okay, and then from there, we just have to finish solving it out. Okay, I'm going to give you guys a heads up. This thing can't really factor. So since it can't factor, let's go to the next best thing. Let's use the quadratic formula. So R2 is equal to negative b, so it's 100 plus or minus the square root of b squared. So 100 squared is 10,000 minus 4 times a times c all over 2 times a, so 2 times 1. Okay, so R2 is equal to 100 plus or minus, and if I do all this 10,000, 2,500 times 4, and negative 2,500 times a negative 4, That's basically giving us 10,000 plus 10,000 inside there, so 20,000 inside of our square root sign, all over 2. Alright, so cleaning up the square root of 2,000, we can write that obviously as 2 times 10,000, and the square root of 10,000 is 100. So r of 2 is equal to 100 plus or minus 100 square roots of 2 all over 2. And let's finish reducing this a little bit because 2 divides into both of those coefficients. So r2 is equal to 50 plus or minus 50 square roots of 2. Okay. And if we plug both of these into our calculators, we obviously don't have to go with the 50 minus 50 square roots of 2 because that's going to give you a negative answer. And you can't have a negative resistance. So the only one we really have to go with is just the positive form right there. So 50 plus 50 square roots of 2 is roughly 120.7 ohms. Okay, so that's what R2 can equal. And from there, it wanted us also to find R1. Well, the easiest way to find R1, let's come back up here just for a second. So it tells us that R1 is 4 times R2 plus 100. Okay. So R1 is 4 times R2 plus 100. So then R1 is going to be 582.8 ohms. Box that up and we can call that done.